Let us apply log on both sides. We'll get log y is equal to x into log x. So we need to find out the value of x and y such that the second order derivative of this equation is less than 0. To get the maximum and minimum value, first we need to find out the first order derivative and find the points of x or the values or roots of x. Hello everyone, a warm welcome to one and all. This is your Shruti ma'am lecturing in Vidhyaashram, the Temple of Excellence, Mysuru. Here in this session, we are going to continue with the revision of the chapter Application of Derivatives. And here in this session, we are going to discuss on 3-mark question. So let's see the distribution of marks from this chapter. So we have 1 2 marks question and 2 3 marks question. Overall, 8 marks we will get from this chapter. So here, the first question is, the volume of a spherical ball is increasing at the rate 4 pi cubic centimeter per second. Find the rate of increase of the radius of the ball when the volume is 288 pi cubic centimeter. So here, volume of a spherical ball is increasing. That means they have given change in volume, that is dV by dt. So dV by dt is given as 4 pi cubic centimeter per second. Next, we need to find out the change in radius, that is, or increase in radius, that is dr by dt. And we need to find out dr by dt when the volume is equal to 288 pi cubic centimeter. So when we are talking about the spherical ball, we know that V is equal to 4 by 3 pi r cube is the volume. Now, we need to find out r here. So, volume is given, that is 288 pi they have given is equal to 4 by 3 pi into r cube. On solving this, we will get r cube is equal to, we will get 216. So, therefore, r is equal to 6 centimeter we will get. Now, let us consider this equation. V is equal to 4 by 3 pi r cube. So, let us derive it. So, we will get dV by dt is equal to 4 by 3. Pi is constant. So, these are all constant. R cube, when you derive it, it becomes 3r square into dr by dt. Now, here dV by dt is given, that is 4 pi. Let us write here. We have 4 pi is equal to 4 pi by 3 into 3. R square is 6 square. We don't know what is dr by dt. We need to find it. So, 4 pi get cancels. 3 and 3 get cancels. So, therefore, here we can write change in radius, that is dr by dt, as 1 by 36 centimeter per second. Next question. A ladder of 15 feet long leans against a smooth vertical wall. If the top slides downwards at the rate of 2 feet per second, find how fast the lower end is moving when the lower end is 12 feet from the wall. Now here, we'll consider a wall and let us consider a ladder is leaning against a wall. So let us take this in the form of a right angle triangle here. So A, B, C. Let me consider this distance as y and this distance as x. Now they have clearly say the length of the ladder is 15 feet. And they have also mentioned that the top slides downwards at the rate of 2 feet per second. That means they have given dy by dt. So this slides down. So that is given as 2 feet per second. Now, when the top of the ladder slides down, so the bottom of the ladder moves that side. So, we need to find out the change in lower end of the ladder from the wall when the wall is exactly 12 feet away from the bottom of the ladder. So, here what is given? X is also given, that is x is equal to 12 feet. Now, since the given problem looks in terms of right angle triangle, we can apply the Pythagoras theorem here. So, I can write AC square is equal to AB square plus BC square. So, AC is 15 square here. So, AB can be taken as y square, BC also can be taken as x square or 12 square. So here we will get 225 minus 144, that is equal to y square. So we'll get the value as 81, or y can be taken as 9. Now let us consider the same equation in terms of x and y. So we have here 15 square is equal to y square plus x square. So let us derive this equation. We'll get the constant as 0. This can be written as 2y into dy by dt plus 2x into dx by dt. Dividing by 2 throughout the equation, we can rewrite this equation as x into dx by dt plus y into dy by dt is equal to 0. So let us substitute the value of the x here, that is 12. We need to find out dx by dt. Y we have got it as 9. dy by dt is given as 2 is equal to 0. So here we'll get dx by dt is equal to, we can shift here to that side. So minus 18 divided by, here we have 12. So dx by dt is equal to minus 3 by 2 feet per second. So this is the change in lower end of the ladder. Next question. Find the maximum and minimum value of the function f of x is equal to 2x cube minus 3x square minus 12x plus 12 here. So we need to find out the maximum and minimum value. To get the maximum and minimum value, first we need to find out the first order derivative and find the points of x or the values or roots of x. Then we will find out the second order derivative. So then we will find out the maximum and minimum value. First let us find out f dash of x. So what is f dash of x? Deriving this, we'll get 3 2s are 6x square minus 3 2s are 6x minus 12. So let us put f dash of x is equal to 0. So then we will get 6x square minus 6x minus 12 is equal to 0. Dividing throughout by 6, we will get the equation as x square minus x minus 2 is equal to 0. So here we can write this as x square minus 2x plus x minus 2 is equal to 0. So we can take x as a common factor here and 1 as a common factor here. So we'll get the roots as x minus 2 and x plus 1 as 0. So this implies we can take the values of x as 2 or x is equal to minus 1. Now let us take the second order derivative, that is f double dash of x. So we have 6x square minus 6x minus 12 as f dash of x. So deriving it, we will get 6 2s are 12x minus 6. Now let's see f double dash of x at point 2 and f double dash of x at x is equal to 1. Now let's take f double dash of 2. So we will get 12 2s are 24 minus 6. So that is equal to 18, which is greater than 0. So if the second order derivative is greater than 0, this implies f has minima. So therefore, the minimum value is f of 2. So let's put 2 in the equation here. 2 into 2 cube will get minus 3 into 2 square minus 12 into 2 plus 12. So here we'll get 2 power 4, 16 minus 12 minus 24 plus 12. So this is equal to minus 8. Next, we will take x is equal to minus 1 here. So we have f double dash of x is equal to minus 12 minus 6, which is equal to minus 18. So here less than 0. So whenever the second order derivative is negative, therefore we have maximum value for the function f. So f has maxima. So therefore the maximum value is f of minus 1. So let's put f of minus 1 in the given equation. So here we have 2 into minus 1 whole cube minus 3 into minus 1 whole square minus 12 into minus 1 plus 12. So here we'll get minus 2 and minus 3 plus 12 plus 12. So the value will be equal to 19. So 19 is the maximum value of the given function and minus 8 is the minimum value of the function. So next question, find two positive numbers whose sum is 14 and the sum of whose squares is minimum. So given two positive numbers, let me consider it as x and y. That is, they have given x plus y is equal to 14. So let me take y is equal to 14 minus x. Also, they have mentioned that sum of its square is minimum. So that means x square plus y square is minimum value. So let me take s is equal to x square plus y square. So s will be equal to x square plus 14 minus x whole square. So s is equal to x square plus, so 192 minus 14 twos are 28x plus x square. So I'll get s is equal to 2x square minus 28x plus 102. Now let me derive this with respect to t. So we will get ds by dt is equal to 4x minus 28. Now let me put this first order as 0. So we'll take 4x minus 28 is equal to 0. So 4x is equal to 28. So x is equal to 7. Now let's check for d square s by dt square. So that is, we are deriving 4x minus 28. We'll get it as 4. Clearly it is less than 0. So therefore f has minimum, or we can say f is minimum. So condition is satisfied. We can take x is equal to 7. Now from the equation we have taken y is equal to 14 minus x, which is 14 minus 7. So therefore y is also 7. So the numbers are 7 and 7. Next one, the surface area of a spherical soap bubble is increasing at the rate of 0.6 centimeter square per second. Find the rate at which its volume is increasing when its radius is 3 centimeter. So what is given? Change in the surface area is given. So let me take it as dA by dt, which is given as 0.6 centimeter square per second. Next, I need to find out change in volume whenever the radius is equal to 3 centimeter. Now, since we are talking about spherical shape here, so area of a sphere is given by 4 pi r square. So let me derive it with respect to t. We will get dA by dt 4 pi into 2r into dr by dt. So now here dA by dt is given, radius is given. So here let me take dA by dt as 0.6. We have 4 pi, 2 into 3 will take here dr by dt. So we need dr by dt. So is equal to 0.6 divided by 6 fours are 24 pi. So dr by dt will be equal to 0.025, so centimeter per second. Now we got change in radius. Let's apply it to find the volume. So we know volume is equal to 4 by 3 pi r cube. So change in volume is 4 by 3 pi 3 r square into dr by dt. So we have dv by dt is equal to 4 pi by 3 r square. R is given as 3. 3 square is 9. 9 3s are 27. So now here after deriving we are get dr by dt as 0.025 divided by pi centimeter per second. Now let us find out change in volume here. We know that V is equal to 4 by 3 pi r cube. Therefore change in volume can be written as 4 pi by 3 into 3 r square into dr by dt. Let us substitute the values. We have 4 pi by 3. R is 3, so R square is 9. 9 3s are 27 into this is 0.025 divided by pi. Pi and pi get cancels. 3 1s are 3 9s are. Let's multiply the remaining values. We'll get 0.9 cubic centimeter per second. That is dV by dt. Change in volume. Next question we have, show that x to the power x is minimum at x is equal to 1 by e. We need to show that the second order derivative is greater than 0. Now let's take y is equal to x power x. Let us apply log on both sides. We'll get log y is equal to x into log x. Let us derive this. We'll get 1 by y into dy by dx is equal to, let us apply the product rule. First function derivative of second plus second function derivative of the first. So we will get dy by dx is equal to y into 1 plus log x, or we can write it as x power x into 1 plus log x. Now let us find out the second order derivative, that is d square y by dx square. Again we have two more functions here. We can either consider this as y into 1 plus log x. So let us apply the product rule here. So we have y first function into derivative of the second, we will get 0 plus 1 by x plus second function 1 plus log x into derivative of the first, that is dy by dx. So now in the place of dy by dx, we can substitute y into 1 plus log x. So we will get d square y by dx square is equal to y by x plus y into 1 plus log x whole square, or we can take y into 1 divided by x plus 1 plus log x whole square, or we can take d square y by dx square is equal to x to the power x 1 by x plus 1 plus log x whole square. Now at x is equal to 1 by e, at x is equal to 1 by e, this implies d square y by dx square is equal to 1 by e to the power 1 by e. So 1 over 1 by e becomes e plus log of 1 by e whole square. So we know that e is a positive quantity. So here the complete term is a positive quantity. So clearly we can write here d square y by dx square is greater than 0. So therefore f is minimum at x is equal to 1 by e. Next question we have, a man 2 meter height walks at a uniform speed of 6 km per hour away from the lamppost of height 6 meter above the ground. Find the rate at which the length of his shadow is increasing, rate at which the tip of his shadow is moving. So we have a lamppost of 6 meter here. A man is moving away from the lamppost at the change in speed 6 km per hour. Suppose I take this distance as x, I can write dx by dt as 6 km per hour. Now as he moves away from the lamppost, his shadow also increases. So let me consider this distance as y. So now I need to find the change in the shadow, that is dy by dt, as well as rate at which the tip of the shadow is moving. That is, if you consider this as the tip of the shadow, we need to find in the change in the movement of the tip of the shadow also. So let me consider the whole distance as z here. So here I need to find out dz by dt also. So suppose a man comes here. So let me consider this as the change in the man moving away from the lamppost, and this is the change in shadow, and this total length will be the tip of the shadow moving. So let me consider this as A, B, C, D. Now from the figure, we have two triangles, that is triangle A, B, this is CD, I'll consider this as E, A, B, E and C, D, E. I can write AB by CD, that is equal to BE by DE. So let me consider this equation 1. So the height of the man is also given, that is 2 meter. So let us write the ratios. We have 6 divided by 2. So here BE means the total length. We can consider it as x plus y. And here this is y. So we have 3y is equal to x plus y, or I can write 2y is equal to x. Let me consider this as equation 1. Now let me differentiate this equation, then I'll get 2 into dy by dt is equal to dx by dt. So dx by dt is given, that is 6 km per hour. So I can write dy by dt is equal to 6 by 2, which when cancels I'll get 3 km per hour. Now here dy by dt is given here. Let me consider z is equal to x plus y. So let me consider this equation 2. So then I can write dz by dt is equal to dx by dt plus dy by dt. So dx by dt is given as 6. Dy by dt we have found it as 3. So total will be 9 km per hour. So therefore the change in the length of the shadow is 3 km per hour and the change in the tip of the shadow is 9 km per hour. Next question. The edge of the variable cube is increasing at the rate of 6 cm per minute. How fast is the volume and its surface increasing when the edge is 10 cm long? So here we have a variable cube. So we need to find out the area and volume of the cube. So edge of the cube means the side length of the cube is increasing at the rate of 6 meter per minute. Let me consider A as the edge of the cube. Then the change in the edge with respect to time is given by 6 centimeter per minute. Now we need to find out the change in volume as well as the change in surface area of the cube when the edge is 10 centimeter long. So volume of the cube is A cube. So therefore dV by dt will be equal to 3a square into dA by dt. So that is 3 into 100 into 6. So 3 6 are 18, will get 1800 cubic centimeter per minute. Next we have area, which is side into side. So do A by dt is given as 2a into dA by dt. So 2 times 10 into 6. So 2 6 are 12. So 120 square centimeter per minute. So this is the change in area. Next question, we have divide the number 40 into 2 parts such that their product is maximum. So we need to find out the value of x and y such that the second order derivative of this equation is less than 0. So now let's find out. Let me consider 40 as x plus y. So then I can take y is equal to 40 minus x. Clearly I need to find out the product. I'll take it as x into y or x into 40 minus x. So product will be equal to 40x minus x square. Now differentiating on both sides with respect to x, I'll get here 40 minus 2x. Now put dp by dx is equal to 0. So I'll get 40 minus 2x, this is equal to 0, or 2x is equal to 40, x is equal to 20. Now when x is equal to 20, clearly from the equation we can get y is equal to 20. Let us check the second order derivative of p. So here we are getting 40x minus x square. When we derived, we got it as 40 minus 2x. Again, when you derive it, you get this as less than 0. So therefore, this is minima at x is equal to 20 and y is equal to 20. So these are the few questions you can expect from the chapter Applications of Derivatives. So we'll meet you in the next session with the new chapter. Until then, keep watching, keep learning, keep exploring. Thank you.